Good evening, popular astronomers. Welcome to Pop Astro Live, live from beautiful stargazy Anglesey. And I'll just play the theme tune and the countdown while people join the feed. In the meanwhile, start sharing. Please start sharing. And pray to God that my internet is going to be good because I'm on my travels. Where am I tonight? I will tell you in just a moment. I am back, reunited with my mug. I didn't take it on my 3 weeks travels with me. So where do you think I could be? The water is musty this evening. I can smell fresh bedding. So guess where I am? I am back down in that there is a laundrette where I used to broadcast from all winter. It's very cold in the winter because the room is made out of glass, and it's very hot in the summer. So excuse me if I've got a slight sheen on my face this evening. Let's have a look what the comments are. Hi, people. Okay, let's have a look. Bob is saying, hi, Vicky, good evening. Please don't send Cosmo into a black hole. Perfect internet. Cosmo is being kept on a tight leash tonight. But more about that pestering, mithering sloth later on. Graham is saying, hi, people. It's been good to have some clear skies in the last few days and also no moon. So hopefully you've got some quality astro done. Oh, Jerry, my beloved, where have you been hiding? Where have you been hiding? We've missed you. Maybe you were here last week. I don't seem to recall that you were. I hope your everything is going really well for you. Madeline Dunn, the lady with the pussycat face. Evening, Vicky. D, the double D. Hi, Vicky and everyone. Good to see all of the regulars in the chat room. And if you are brand new to Pop Astro Live, then welcome. Please join in with the comments. It's your show. Make new friends. Friend request people on Facebook if you're that way inclined. Friend request me. It's great to have you all on my Facebook. And one of the reasons that we do this show is to keep astronomers connected because we all know what a great social life that we can have. Let's have a look. Hi, Vicky and the crew. Nice to see you all again. Hello, SPA viewers. Thank you. Hiya, folks. It's the man with the stars for his face. And our little Jed, there he is. There's Eleni hiding in the chat room. Hope she's all right. Hi, Eleni. You're all right there. I can see her in the green room. Eleni will be along with the space news about Eleni. So please share the video. Each algorithm and Facebook ranks the video's popularity depending on this video is shared within its first couple of minutes. So please get sharing it. Plus, it helps spread the word of the society. This little video might just end up on the feed of somebody who doesn't know a thing about space, and suddenly that bug, or the bug might catch them, as it were, and they may become a huge space fan just because you shared that video. And get your kids watching it as well. It's kid friendly. Look, we've got cuddly toys. What do you mean you're not a cuddly toy? Let's see what the comments are. Oh, just a little bit of internet stuttering. It's really mad. I'm right next to the internet cabinet. But hi, Jerry. Not looking good for NLC. I'm my very best. Not looking good for NLC observing tonight from the south of England. 8 octus cloud here in. Okay. Were there octolucent clouds? I nearly call them 8 octolucent clouds, noctilucent clouds a couple of nights ago, because I was up at about 11 o'clock in North Wales, and there were white clouds quite a couple of hours after sunset, but they did disappear. So I don't know whether they were just vapor trails catching the last bit of the sunset or whether they were the real deal. Okay. So what have you seen in the sky this week? Many astronomy points if you managed to get a photograph of Venus. I know Paul Sutherland did, but he doesn't count because he is family and friends of the SPA. So he doesn't count. So let me know if you've seen Venus. Ian is saying, great to see you. Have Dr. Becky on tonight. One of my favorite YouTube channels. Yes, she's got a YouTube channel. Brilliant. Hi, Eleni. Hi, Sonia. You are looking great from the Wirral. Thank you very, very much. Now, it's very windy here on Anglesey. We're the fourth windiest place in the UK. I've just been for a walk by the seaside with my friend. My brand newly washed hair has just been blasted into what could only be described as a hair supernova. So thankfully, I had my space cap handy in the car. Can you see what's on the side of it? Can you read that? What does it say? Onions, onionettes. It's my beloved Julian Onion. I nearly called him Juliet then. My Julian Onions badge is my brooch, made for me, I think, possibly by Sarah, who runs Solarsphere. So thank you very, very much for that. That is a very beloved possession of mine. And if my house was burning, it would definitely be in the top 3 possessions that I jumped out of the window with. So I have been away at my mum's house. I've been on a 3-week expedition. The car has got so much stuff in it. It's got winter clothes in it, because when I went, it was winter. It's got summer clothes, it's got party clothes, and it's got all my broadcasting gear. So my lovely Sarbine is packed to the gunnels with gear. So I spent 2 weeks at my mum's house. It's so lovely to see my mummy. There's no way she's watching this, but I do love her very, very much. She is the most incredible cook. Do you know what she cooked? If you like seafood, oh my God, it was so beautiful. She got squid and stuffed them with black pudding and baked them in the oven with a spicy tomato sauce. And that was probably the best thing I ate all holiday. Then I went to a 3-day garden party last weekend. And now I've just come back from a holiday cottage in North Wales. So I am well rested, nice and tanned. And this is a very historic Pop Astro Live, because it's the first Pop Astro Live that I've ever presented wearing shorts. So there you go. And I'm sticking to the chair. So there we go. So on the show tonight, we have got a mixed bag of cosmic delights for you, alongside Eleni and Sonia's presentations, which tonight Sonia's presentation is about the asteroid belt holding up the solar system's trousers. We have got Becky Smethurst on supermassive black holes. There's also recent news of the nearest smallest black hole to Earth that's been found. Cosmo has been exploring and accidentally fell inside and came out looking like a mile of spaghetti. So we've managed to scrunch him back into his normal shape. We pulled him out with a bit of tinsel. And we saved him. Who knew that a bit of spangly tinsel could rescue a sloth from spaghettification is a sentence that has never been said in the history of the universe before. So after that, we have got Peter Allen with how the times of sunrise and sunset change throughout the year and why noon is not usually at noon. That sounds very basic, but you can use it to show that the Earth's orbit has to be elliptical, not circular, just by noting the times of sunrise and sunset. We'll also touch on measuring the speed of light by observing the moons of Jupiter, and Peter has got a fantastic puzzle for you at the end. So sit tight. Okay, we have got all the fun and the friends in the fast-moving chat room. Hi, Vicky's mum. Look, we even get shout-outs for my mother off random people who live on the Wirral. Thank you very much, Jed. I know that you saw a snapped Venus a couple of nights ago, Paul, but that doesn't count because you are an employee of the SPA and you are thereby disqualified from taking part. The family, so Jerry, let's see. Let's catch up with what Jerry's doing. I've actually moved into sheltered accommodation. It's very nice, but is totally unfurnished. Do we have to crowdfund you a poof and a TV cabinet, Jerry? Jerry said, the family has helped me out, but I've got all kinds of things. I still don't have a TV or a broadband. I'm watching this on my phone. Oh, Jerry, well, we're still just as wonderful on the phone. Thank you very much for your lovely comment. Seas on the night of the 29th. Very low in the north. Other reports from south. What was I doing on the 29th? I can't even remember where it was. Maybe I saw them. They were quite high in the sky, actually, so unlikely to have been NLCs. Sometimes they do come right up. Do you remember Midsummer's Night a couple of years ago when they came all the way up to the zenith? The zenith. I need to say that properly. When they came all the way up to the zenith. There we go. Very good, Jerry. I'm pleased for you that you finally got your accommodation sorted. And sheltered accommodation can be quite cushy, can't it? It's got table service when you ring your bell. I have been trying to image the sun today, practicing for the partial solar eclipse next week. Blinking clouds, still a nuisance. Oh, I'm so sorry. How's my internet doing? My internet warning light is on, so hopefully it's holding up. Right, okay, so let's go over to Becky now. She is waiting in the green room, so we shall introduce Becky. And then Cosmo will be along with Where Has He Been? And you have to guess. Isn't that great? Okay, so we're coming over to you in 3, 2, 1, Becky. Hello.
Hi.
Good evening, Becky. How are you today?
I'm good. There's sunshine here. Look, we could take pictures of the sun.
Very nice. Yes, very nice. Oh, so I'm being told my internet is good. I've had a year of internet. Good. I've had a year of internet tribulations, guaranteed to give you grey hair, Becky. But yes, where are you tonight?
I'm in Oxford. I'm at home, as we all are, I think.
Yeah. So, how have you been celebrating coming out of lockdown, Becky?
I went back up north for the first time in about a year, and it was great. It was so nice to be back up, see family. That was really nice.
More friendly?
Yes.
North as well, of course. We put on a good show, don't we?
Yeah, exactly. But yeah, it was like up round sort of Rivington way, near family. So lots of walks in hills.
Oh, that's lovely. Yeah, I was in where was I? Oh, that's so nice. Yes, so that's nice. So tell us a little bit about what you do then, Becky.
Yeah, sure. So I am an astrophysicist. I am a researcher at the University of Oxford, and I study supermassive black holes. And specifically, they're found at the centers of galaxies. And we think, or this is the main theory at the minute anyway, is that by growing a black hole, you cause that black hole to actually output energy. So not the black hole itself, but from the regions around the black hole where you've got matter spiraling in and the pressure is getting really, really great. The black hole kind of like does a burp. That's what I like to call it. And it burps outwards this energy, and that can impact on the galaxy that it lives in. And that can cause heating of gas or even expulsion of gas, which means you can't form any new stars in the galaxy. So I look at the link between what happens when you grow a black hole, and then what happens to the galaxy. And if we can actually see that in observations that we take with telescopes. So I'm an observer, which I'm sure amateur astronomers will be happy to hear that there are observers still out there amongst us. So I look at images of galaxies and look at their colors and look at their spectra. When you split the light into its component wavelengths and you look for signatures of hydrogen, so that stars forming, and you can tell whether something is forming stars or not forming stars, and you can have a look if the black hole is growing in the middle, and you can sort of try and connect the dots and see if there's a correlation there.
Wow. Well, actually, speaking of the colours, the fashion aesthetic of this show tonight has been. So, can you see the way we've got tonight, Becky?
Oh.
Can you see that the banners?
Yes, the orange. I can see the orange. Sorry, you dropped out for a second there. The internet.
Yeah,
you should have told me.
Yeah, can you see my hat is orange?
Yeah. If I got the memo, I would have worn orange.
Okay, well, there's a reason why my lipstick is kind of red, and there's a reason why, because and the background is Mars as well, which is a bit orangey. There's a reason why. Now, I don't know whether any of the popular astronomers have ever actually noticed that I do color code the banners to match my outfit, but there's a reason why, because look what I'm wearing. It's coming up. What do you think that could be on my t-shirt?
I think I can guess. It's a big orange donut. Nice.
Yay!
That's a great t-shirt. I'd never thought about getting a t-shirt with that on. That's amazing.
Well, I saw it. It was actually preposterously expensive for a t-shirt. It was 28 quid, and it took 3 weeks to arrive from China. But at least I got it.
Yeah. Do you get stopped by Lord of the Rings fans who think it's the Sauron?
Actually, yeah. No, it's a black hole. Go away. It's not the Sauron.
Cool.
Yeah. So there we go. So the fashion aesthetic of the show tonight has been governed by the black hole. What is this on my t-shirt, Becky? Give us a reminder.
That is the supermassive black hole at the center of the Messier 87 galaxy.
Ooh.
It is about 4 billion times the mass of the sun, and yet you could fit the solar system inside it.
Oh, it's so big. Wow, that's huge.
Yeah, I mean, well, the thing is that we talk about like 4 billion times the mass of the sun. That is massive. It's super massive. But then actually the size of it is actually kind of small in comparison, like the actual physical size. Ooh, did I take part in the Event Horizon Telescope experiment? No, I didn't. I hadn't even thought about that. On Netflix as well.
Wow.
I wish. That sounds like my kind of people. I'm like, what did I hear about this?
Okay, so now then, there's been some recent news about a mythical beast trotting across the skies. What would that be?
Yeah, so we've got a new candidate for not only the nearest black hole to us, but also the smallest black hole we've ever found as well, the least massive black hole we've ever found. And it was, oh, hi, Supermassive Podcast listeners. Hooray. I love that podcast. I am co-host along with Izzy Clark. And what was I talking about? Yes, this new black hole they found. They've dubbed it Unicorn because it was found in the constellation of Monoceros. And because black holes of this size are also very rare, they were like, let's dub it Unicorn because unicorns are also very rare. And I love that they've done this, but it's only about, I think it was something like 3.5-ish times the mass of the sun, and a couple of tens of light years away, if I remember right. So it's fairly nearby, nothing to worry about. Black holes aren't hoovers. They're not going to suck us in. Nothing to worry about. But I just love the fact that it's only about 3 and a bit times the mass of the sun, because this is sort of like where we're getting towards like the limits of what's a neutron star, what's a black hole, what can a supernova, when a star dies and, you know, runs out of fuel and collapses down, at what point does it make a neutron star? At what point does it make a black hole? And we're right on that limit. So yeah, it's a really, really cool discovery.
Oh, I'm sorry. I've just realised I've been bigging up a T-shirt that isn't actually SPA property. So other T-shirts are available. You have to get this one in stock, Paul. I think it'd sell out, and I'm sure you could think of a way for it, Paul. Right, okay. So how big is this, the baby black hole then?
Yeah, so it's 3-ish times the mass of the sun, so it's a lot smaller than the sun. Let's put it that way. We could work out the radius, but I need a calculator probably to do that. Can't do that off the top of my head. General relativity, but yeah, I mean, it'd be smaller than the Earth probably at that mass. But what's really intriguing about it is how they found it as well. So, are you familiar with the way that we find exoplanets, where sometimes we find exoplanets where they pass in front of a star and the light dips from them, but they have to be like perfectly aligned to do that. So the other way that we do it is we actually look for the star wobbling, right? Because if it's a very large planet orbiting the star, it won't be that the planet orbits the star. They'll orbit like the center of mass between them. So they'll do this. If you can't see one of those things, like you can't see a planet, you see the star doing this on the sky, and you get a little red shift and blue shift as it comes towards and away from you. And so the way that they found this black hole was because this star was massively red shifted and blue shifted, way more than a planet would be able to, because it depends on how big the thing is that's orbiting around this star. So because this thing was so massive and we couldn't see it, it was like, it's probably a black hole. It could be that it's like 2 neutron stars, but it's much more likely that it's just a single black hole. And so, yeah, it's really exciting that like it's a candidate, but it's still a very exciting candidate that it could be a black hole, and especially that it's called Unicorn. Oh, thank you. Was that Ged or Jed? I'm not sure, but thank you for recommending my book. I had fun writing it. So.
Very good. So, if there were planets around the star, what would be happening to them?
Oh, yeah, they would be in some strange orbit. So we'd be considered like planets in binary stars. So either 2 stars or a star in a black hole, like in this case. Like, what would the orbits look like? The stars themselves would be so far apart that you probably still would have planets in orbit around the single stars. But there'd probably some weird like tidal effects going on. So, you know, Venus, like its day is longer than its year because it's tidally locked. So sort of one side of the planet always faces the sun, in the same way that our moon, like one side of it always faces us, right? We only see one side of the moon. You'd probably get stuff like that happening, or you'd get a resonance between the planets and this other star, or perhaps a black hole as well. So I remember someone once asking me, like, if you had a planet that always was like the same exact distance from both stars, and so sort of stayed in the same place, there was always 2 day sides, like you would never have night, so you would never be able to do any astronomy. And I was like, why would you even contemplate such a fact?
Very good, very good. Jim is asking, is it known at what point black holes eject material? Is there a critical mass?
Yeah, so just to reiterate for those of you who it's not material from the black hole itself, it's from the region around the black hole. So to get this point where the pressure is so big that the only thing it can do is eject material from this disk that's sort of swirling around it, trying to sort of vie to get into the black hole. It's really only supermassive black holes that do this. So we start classifying a black hole as supermassive as around about the 1,000,000 times the mass of the sun mark. But they could do it at much lower masses. It's just that we probably wouldn't detect the light, the emission that comes from that material that's thrown off as well. It has to be incredibly energetic for us even to be able to see it, right? Most of the time it is X-rays, or it hits into some oxygen or some hydrogen on the way out and makes that glow, and that's how we know that stuff is there. But sometimes it's these huge big radio jets that you see as well. So yeah, it's really cool to think about that. At what point do you have that? And most of the time for these massive radio jets, it's things like in the Messier 87, the big orange donut on your t-shirt, right? It's the ones that are getting towards like 1 billion times the mass of the sun. And Alan, thank you, Mr. Google, for Schwarzschild radius of a 3.5.
At least he's honest. At least he's honest that you got it off Google.
Yeah,
I mean, everything comes from Google eventually, doesn't it? Well done, Alan. Thank you for your honesty. Yeah. So what? Just talk us through that question. I did say it was smaller than the Earth, so yeah. So you can work it out, because basically all you need to know is the mass of the black hole, and then it's kind of like working out what velocity do you need to escape from the surface of the Earth, right? If you were going to launch a rocket, what speed would it need to be going at? How much energy would it need to escape the gravitational pull of the Earth? It's the same calculation for the black hole. You work out the radius at what point you would need to be traveling at the speed of light to escape it. And that's at 10.4 kilometers. So I think it's 2gm over c squared for anyone who wants to know the equation. So you want to plug those numbers in. Great. Well, thank you for educating us on black holes, supermassive, and the unicorn type. Tell us a little bit more about your outreach that you do. So you've got a podcast. That would be a great name for a dessert podcast.
Yes, where you just eat pudding all the time. Oh,
I've had so much pudding. I've had ice cream. I've eaten so much chocolate orange birthday cake. I am just a pudding at the minute. So, so the podcast, your podcast and your book.
Yeah. So I do a lot of different things. The podcast is with the Royal Astronomical Society. So they launched a podcast at the beginning of last year in January for their 200th anniversary year, their bicentennial year. It's called the Supermassive Podcast, and it's myself and Izzy Clark, who's a science journalist, and also Robert Massey, who's the old head of the Royal Astronomical Society. And it's a bit of space news, and it's a bit of what you can see in the night sky as well each month. But it's also sort of like got a theme. So this month's theme was on Planet 9 in the solar system, whether there is a Planet 9 beyond the orbit of Neptune, not Pluto, whether it could be a tiny black hole itself, Planet 9. So that was a really fun episode to film, to record even. And then I wrote a book called Space 10 Things You Should Know. That's the name in the UK. And it's a sort of 10 short little chapters on the 10 biggest ideas in astronomy right now. And then I also make a weekly YouTube video as well on my channel, Dr. Becky, which they range from everything from unsolved mysteries and weird things and weird objects in space to space news. So there's a video just come out tonight that's all about the huge big data dump we had last week from the Dark Energy Survey, which surveyed about 1/8 of the night sky in the Southern Hemisphere and catalogued 226 million galaxies. And all the positions and distances. And so with that, they've been able to essentially probe, like, where is dark matter distributed, find that it's probably smoother than we originally thought. And then also the effect of dark energy as well, this force that's perhaps causing this accelerated expansion of the universe, and try and get at what it actually is as well. And weirdly, they can do that with this data. So that's what that video was about. And also have a monthly recap of space news and what to look out for in the night sky. So we were talking about the eclipse that's coming up. 9 days? No, not even 9 days. It's like 7 days time. Like, I'm so excited for that. So
I had it's not often I have a theories. Although one day I did invent panspermia all on my own. The theory that light travels through the universe in pieces of So I came up with that on my own. And then I thought the other day, there's a theory that the universe is a series of simulations, right? Where everything is possible. Every combination is possible. And I reckon our one is basically they went to print out our amazing 10-dimensional universe, or however many dimensions they postulate. And they got the parameters wrong. And they were like, oh, no, we've just spent all this time and effort on printing materials and programming it. And we've accidentally set the galaxies to expand and accelerate forever. And obviously that was a mistake. And then just go, oh, well, they'll just have to figure it out themselves.
Yeah. And also they were like, oh, but if they're going to measure it nearby, it'll have a different answer if they measure it with the cosmic microwave background from the echo of the Big Bang. And oh, well, they'll just have to figure it out.
Could it just be a programming error? We're on a wild goose chase trying to figure someone's boo-boo out.
I'd hope not. Like, we're just looking for the -1 in someone's code somewhere. It's gone in the wrong place.
Oh, thank you so much for coming on this evening, Becky. I hope you're having a lovely summery evening there in Oxford. And I hope
you.
Thank you for agreeing to come on with us. That's really lovely. And good luck with all the broadcasting. I mean, I only do this one show a week, and I know that it's time consuming, isn't it?
Yeah, a little bit, but it's good fun, and it means you get to you'll have this, you get to connect with a load of like-minded people, like comments section if on YouTube, if approached with a filter. It's a very fun place to be, because you get to just chat science, and people also, people who aren't astrophysicists ask the best questions, because they ask the things that you've forgotten to ask because you're so entrenched in what you do, that you've become so used to everything, that they then are they get to sort of the most basic of bit. He's like, oh gosh, yeah, I didn't think how that could play into it. I didn't even think to explain that. So it's really cool to chat with people. I like the jolly black hole info. Wherever I go, I'm like, black hole. It's just very jolly.
Brilliant. And hopefully you can get one of these shirts. Becky, it's been a pleasure. Thank you so much.
Thank you, Vicky. Nice to see you.
Okay, goodbye. Bye. Thank you. Bye. Ah, that's so lovely. Thank you, Becky. Thank you so much. Hi, Becky. Great to see you here. Thanks, Ian. Thank you for all your lovely comments, everybody. Okay, let us do something. Let's press a button. Here it comes. Hang on. Let's get rid of that. Press the magic button. He's been flying around the solar system, or maybe a bit further. But to the casual observer, he's a mithering, pestering sloth. Where have you been to this week, Cosmo? Cosmo, where have you been? 3 clues. Only answer after the clues. Cosmo over and out. Oh, Cosmo, stop crying and screaming. Let me just change my banner. What should I put on? I'll put that one on. Cosmo, I know we fished him out of a black hole on a bit of tinsel, but also he's been somewhere else, haven't you, Cosmo? So we dragged him out of the black hole with a bit of tinsel. The minute he regained his composure, he jetted off somewhere else in his little Cosmo ship, Cosmomobile. Might need to invent something for him. And we're going to read out 3 clues. And if you are good and wait until the end, if you haven't got it right at the end, because these are quite cryptic, I've got a bonus clue for you. So 4 clues. Do you think you can hold on and press the send button until I've read out all of the clues? Hopefully you can, because it's meant to be a brain teaser, not a fastest finger first round. So, right, can I just tell you about my internet? It says it's on 40 megs. So there you go. It's saying it's on 40 megs, yet still I'm getting the weak signal. So I suspect the router might actually be through the wall rather than in the cupboard. But there we go. These things are sent to turn my hair grey. Okay, Cosmo, where have you been? Well, he's very, very scared, and that's not after his expedition into a black hole. Let's see what someone already guessing correct. Been to Vicky's mum's, yeah. Okay, Cosmo is utterly terrified. He needs to stop panicking. Oh, hang on a minute. Yeah, I'm just realizing I'm missing part of a clue. I'll have to Google it while you're guessing. Okay, so this area where he has been discovered by 1877 by American astronomer Asaph Hall. Well, there you go. And It's one of the least reflective bodies in the solar system. So he's absolutely terrified. It was discovered in 1877 by American astronomer Asaph Hall, and it's one of the least reflective bodies in the solar system. And I just need to Google a quick. There we go. There you go. Oh, wow. Okay, nobody's scared. Okay, and I'll give you the fourth clue if nobody's got it by the time I come back to you. Let's have a look. Right, okay. So he's utterly terrified. He's been panicking. It was discovered in 1877, and it's one of the least reflective in the there, Cosmo in the solar. Oh, they're there in the solar system. So where could he have been? Who is going to get it right? Ooh, let's see what we've got. Cosmo, did Jim Roberts get it right? No. Oh, did Graham get it right? No. Jim got it wrong. Graham got it wrong. I'll read out the fourth clue, actually, just because I've typed it out. I've gone to the effort of cutting and pasting off. The defining surface feature is the large impact crater, a substantial proportion of the moon's surface. So they go. Oh, there you go. Who got it right first? Cosmocraft. Well done, Paul. It's now going to be called the Cosmocraft. Graham Clue was the first. No, Graham Clue got it. Sorry, Tim J. Crook got it right. He has been to the Spud Moon. Why is that not clicking? There we go. Tim J. Crook. Cosmo sends you his undying love. Well done. He has been to one of the 2 moons of Mars. So there you go. Phobos. It is a personification of panic in Greek mythology. The personification of panic. That'd be a wonderful fancy dress to go as, wouldn't it? Just spend all night screaming in people's faces and running around with your hands in the air. Ah! For I am the personification of panic. Phobos. Okay, let's have a look. Phobos, yeah, there we go. Everybody, well done to everybody who got it right. Phobos, you lot are a lovely bunch of clued up popular astronomers, aren't you? Now going to go. Oh my God, something crazy's happened, popular astronomers. We're actually running on time tonight. Eleni is scheduled to come on at 8:30, and we have been way far from those times lately. So we're coming over to Eleni now. Here she comes.
Hi, everyone.
Hello, lady. How are you tonight, Eleni?
I'm all right, thank you. How are you?
Are you enjoying the erratic weather?
I'm enjoying the sun. Like I went to the sea twice over the week, so that was really nice. But today it's been a little bit cloudy. It's not bad, but hopefully we'll have more hot days.
Yeah, hopefully, yeah. That must be hard work coming from Greece where hot weather is just guaranteed.
See, I've been here for more than 10 years now, so I should have been used to it, but I'm still struggling.
None of us are used to it.
You keep you're very I can't hear you very well.
Here she is with the space news. It's Eleni. Prepare to be astonished by Eleni. When she's not reading Tolkien or teaching a class, she's doing yoga and toning up a PowerPoint presentation for astronomer emulation.
Right.
Yeah. Okay. I'll remove myself from the feed and.
Perfect. Okay. There we go. So let me make that big for you guys. Right. Just give it a second. Yay, there we go. So I got a couple of things for you this week. And I'm going to start with a new NASA mission called Da Vinci Plus. So this mission is dedicated to exploring Venus. And it's got a very particular goal, if you want. So what we see here is an artist's impression of what the probe will look like. And it will be about 1 meter in diameter. And it will go through Venus's atmosphere and try to get near the surface and try to get a glimpse, of course, some observations of the surface, collect some data of that and some data of the atmosphere close to the surface. And you might wonder, but why Venus? Because so far we haven't really bothered with Venus. It's all about Mars, and Mars is very interesting. But let's not forget that Venus is actually the Earth's twin, right? They're about the same size, and they started off probably from the same initial conditions. So it's really astonishing how they've ended up in completely opposite directions. One is habitable, the other is hell. So what this mission is trying to do is to basically figure out whether or not Venus was habitable at some point, and what probed that greenhouse effect and caused it to become completely inhabitable and, you know, the place that we know it to be today. So if we understand Venus, then we can hope to understand other exoplanets that are at a similar position from the star, like as Venus is. So it's not just about understanding Venus itself, it's about understanding a lot of Venus-like, if you want, exoplanets out there, which are really hard to directly observe and get direct data from. So let's wish the mission good luck, and hope it goes through, everything goes through well, and that we actually get some really interesting data. And of course, whatever happens with that mission, I will keep everyone posted. So I'll move on now from there to something really, really, really interesting. I don't know if you know about Zooniverse, which is if you want, a collective of projects that are citizen science projects. And the purpose of that is to involve the public, to include the public in doing astronomy. There is a lot of data to go through, to sift through. And though there is a lot of AI technology and AI programming to sort through all of these amazing amounts of data, it's not quite the same as if you have someone looking at that data. And this great initiative is actually a way to get people, A, interested in astronomy, and B, included in a very meaningful way. So this particular project is all about helping astronomers find and identify jellyfish galaxies. Now, these galaxies are kind of like a new sort of type in terms of classification. And the basic idea behind it is that when you have a galaxy that moves through intergalactic, hot intergalactic gas, it's kind of like the hairs of a dog when it puts its head out of a moving car and it gets its hairs all flowing back, basically, which is a very crude way of explaining what's happening, but that's the issue. We don't know the details exactly. There's a lot to work out, a lot of details to work out. And astronomers really want to pay a bit more attention in those galaxies that look like they could be jellyfish galaxies. And so they're asking the public to help. So if you want to help, you should go on this link here. And if you don't have time to write it down now, just ask me and I will put a comment under the video on Facebook, because you could actually help astronomers do science. And this also means that you will also be doing science. And I think that's pretty cool. And now, enough of that. Maybe I oversold it. I'm not being paid to advertise it or anything. I just get really excited with these things. So I'm going to move on from that to, as a few people have mentioned already, Vicky and Becky have mentioned already, there is a partial solar eclipse on the 10th of June. It's going to be about 30% coverage of the sun, and it will start about 10 and it will finish around 12:15, I think. So we don't have any auroras coming up, but I think that with this solar eclipse on its way, it kind of makes up for the lost excitement because of the, no auroras. But you know what? We have a solar eclipse. So hopefully that can balance it out a little. Just as a reminder, and I'm pretty sure everybody knows, but I should always say it, never look at the sun directly, never ever, not even with sunglasses. Don't try to watch the eclipse with sunglasses. Just try to get yourself a pair of eclipse glasses. They're about £8 on Amazon, and they will protect your eyes, okay? And if you're not sure how to set the right filters in your telescope, don't look at the sun through the telescope either. Because I will feel awful having delivered this news to people, and then next week someone tells me that they had a burned retina. Just putting it out there, safety first. And I will go on to my last slide for today, which is this beautiful, beautiful picture of Omega Centauri. And as I said, this is my last picture for today, and it's always going to be an astronomy picture of the day. So if you want to track these, you can just Google NASA astronomy picture of the day, and you can see every day what they have in store for you. And it always comes with a scientific description at the bottom, which is really nice if you want to enrich your knowledge. Now, this particular cluster, it's a cluster of stars. It is a globular cluster, and it's one of these clusters that can be found in the halo of the Milky Way. And what makes clusters ideal, star clusters ideal for studying different populations of stars, is that usually they're made up of the same type of star. So the same age, same chemical composition, so you can have really, as I say, homogeneous data set. This particular cluster, which is about 15,000 light years from Earth and is host to about 100 million stars, is very unique in that it actually, as you can see in the image, it's got blue stars and red stars, the red stars being red giants and the blue stars being younger stars. And this is very uncommon. And it has led to a lot of speculation about this particular cluster. And it could even be what's left from a smaller galaxy that merged with the Milky Way at some point in the past. And that's what was left behind. So this is me for tonight. I hope you could actually hear me.
Yeah, we could, yeah.
Perfect. And I don't know.
I've got somebody. Can you hear me?
Yes, perfect.
I want you to meet.
Hi, Dr. Alan.
Hi there, Eleni.
Oh, this is wonderful. I'm so looking forward to your presentation. And the SPA is so lucky to have you tonight.
Well, I hope the audience thinks so.
So
how do you two know each other?
Oh, I did a placement with him ages and ages ago. When was that?
8 years ago.
8 years ago, yes. My first summer placement it was at STFC, and it was amazing. I learned a lot.
What did you learn?
I had never been introduced to coding before, so I learned a lot of that. And I worked on the Hipparcos data for a while, which was like a precursor, if you want, of the Gaia mission, not even close in terms of the amount of data, but it was a great introduction for me to work with a big data set and have a great mentor and learn so much. Thank you so much.
So we've kept in touch since.
Yep.
Excellent. Well, thank you, Eleni, for suggesting Peter. We're going to go over to Peter now. So say your goodbyes.
Bye-bye. Enjoy the presentation, everyone. It's going to rock.
See you soon, I hope.
Oh, lovely. Bye,
See you
Eleni. Thank
soon.
you. Thank you.
Bye.
Thank you. Apologies about the poor bandwidth tonight. Hopefully, I'm not too Dalek-y. Eleni, that was a great presentation. Peter, how are you?
Doing well, thanks. Enjoying the sunshine. Like
Whereabouts are
everyone
you?
else.
Where are you tonight?
Right, so I live in Grove. It's about 10 miles southwest of Oxford.
Okay.
And not that far from the Rutherford Appleton Laboratory, which is where I used to work and where Eleni was working with me those 8 years ago.
Oh, excellent. So, Peter, give us, who are you, by the way?
Right, so I'm Peter Allen, an astronomer for many, many years standing. I used to work on really distant objects like quasars and radio galaxies, jets shooting out of them, the sort of things that Becky was talking about earlier. More recently, I was working with the team that developed the software for processing the data from the Gaia mission.
Oh, nice.
So counting 1.7 billion stars. And I've counted them myself. There's 1.7 billion and so many stars.
Excellent.
But doing proper science with that. What I'm actually waiting for is when the Gaia data will have spectra in it, because then I want to look at quasars with it.
Oh, nice.
However, this evening I thought I was asked a question, and I'll put the question up in a minute, about times of sunrise and sunset. And it occurred to me that this actually gets you quite involved in being able to explain why the times of sunset varied throughout the year. And that leads on to actually doing some real astronomy, not just saying, oh, the sun's risen and the sun's set. So I'm trying to get my presentation up. I don't want to share. There we go. There we go. That looks like it. Right. I can only see my presentation now. Can you see me and the presentation?
I can see both of you, yes.
Okay, right. So it starts with the question. Yep.
Yeah, go on then. Let's have a look.
Right. So this all started because an acquaintance of mine said to me that he had been trying to explain to a smart but non-scientific friend, is how he put it, the relationship between sunset and sunrise as the years go by. And he ended with what he thought was a simple question. If you're living in Greenwich, so Greenwich is the home of mean time, so you ought to know what time is at Greenwich. You're in the winter, the sun rises at 8 o'clock, what time is sunset? So he thought, well, obviously it's 4 o'clock. It's 4 hours before noon when the sun rose, so it'd be 4 hours afterwards. And he thought, well, that's obvious, isn't it? Sounds simple. Except that when he checked the paper, it didn't work out like that. The sunrise was shown as 8:02. Well, that's fine. You wouldn't expect it to be exactly 8 o'clock. That was just a guess. And so the sunset should surely be at 3:58. But it wasn't. When he looked it up, it was at 4:12. And that's 14 minutes difference. And that's not exactly a small difference. So he said to me, how about a simple explanation to be repaid by a drink? I think I'm still waiting for the drink, so I must remind him about that. So what we've got is that the thing about this is that anyone can do these measurements. All you need is an accurate watch. You need a clear, unobstructed horizon, so you can actually tell when the sun's rising, or you can cheat like everyone else does and look it up on the internet. So we've got this simple thing here. The sun rises, it reaches its highest point, otherwise known as solar noon, and then it sets. That's all very simple. You do need to just think, what do we mean by sunset? Because it takes a few minutes for the sun to touch the horizon and then disappear. So we actually define the time of sunset as when the upper limb of the sun disappears below the horizon. So you just can't see anything anymore. And similarly for sunrise, you might think, well, maybe it's when the middle crosses the horizon, and it's not. It's the top bit. So going back to the problem, sunrise was at 8:02, sunset was at 4:12. So I asked my friend, so what are you thinking about? What's your mental model of what's going on here? And I decided that what he was thinking was that the time from sunrise to when the sun reaches its highest point is the same as the time it takes from that highest point to sunset. That seems reasonable. He's also thinking that the highest point of the sun at Greenwich occurs at 12 o'clock, 12 noon. And at least one of these must be wrong, because that's not what the paper, what the internet, what anyone with a watch would see. So this is where we discovered that noon doesn't actually mean noon. Noon means two things. We use it in regular everyday speech as it's 12 o'clock, 12 noon. We also mean the point when the sun is at its highest, and the two things are not consistent. And so rather than thinking about when does the sun rise, when does the sun set, it's better to concentrate on, so when's the sun at its highest point. So the time of day, even at Greenwich, when the sun reaches its highest point, it's normally not at 12 noon. And in the example that I gave before, then it was actually at 12:07. And the important thing is this difference varies throughout the year. It's not just there's an offset and you scratch your head as to why that is. That difference varies. And we have this thing called the equation of time. Now, if anything was ever going to be an episode of Doctor Who, surely this is it, the equation of time. They've never used that as a title for something. And what this is showing, and this is a brilliant example of how astronomers get rubbish at naming things. This is called the equation of time, but there's no equation. It's this graph. So it's really the graph of time. However, that's the name that's used. And what this is showing is that, so along the horizontal axis, this is just the day of the year. So it starts on the 1st of January and goes along up to the 31st of December. And what the line shows is that when you're above the horizontal axis, then a sundial, or the position of noon, relative to a watch, it will appear fast. When it's below, it's slow. So it varies quite a bit during the year. It might be, about 16 minutes fast. It might be about getting on for 15 minutes slow. So there's this variation throughout the year. Okay, so we can see that. And in fact, my friend's measurement was where this red cross has now appeared. So that's about 7 minutes out. So this is what's going on. But why is this happening? Does this mean that the length of a day is not 24 hours? And that obviously depends on what you mean by a day. So there are actually two definitions of a day. The one we normally use is it's 60 times 60 times 24 seconds. That's what your clock says. But also, we've got the time between when the sun is at its highest point on successive days. We call that a solar day. And those are not consistent with each other. So again, why is this happening? What's going on that gives us this very strange thing? So, how long is a day? Oops, why is... there we go. Sorry, I seem to freeze there. So the sun appears to move across the sky because, of course, the Earth's actually rotating on its axis. And it rotates on its axis once every 23 hours, 56 minutes, not 24 hours. And that's how long it takes a star to move around the sky. Now, in this time, the Earth's moved in its orbit around the sun a bit. So it's moved forwards a little. So for the sun to return to its highest point on the next day, it actually takes an extra 4 minutes. And that gives you the 24 hours. And that adds up to 24 hours. Okay, fine. So why is the time of noon changing? And the reason for that is the orbit of the sun, Earth around the sun isn't a perfect circle. So when the Earth's close to the sun, it's moving a bit faster. So the sun takes a bit longer to return to its highest point on the next day. And when it's further from the sun, it's moving a bit slower. So you get this variation, which is what the equation of time shows that's going on. So simply by noticing what the times of sunrise and sunset are, and hence working out when the time of the solar noon is, you can actually show that the orbit of the Earth around the sun must be elliptical, and it's not circular. So you've done some actually serious astronomy using a £10 digital watch. That's not my watch, that's just a picture I got off the internet. So I find it interesting that you can do some serious astronomy like that without actually even looking up at the sky at night. You're working out what the orbit of things in the solar system is. Right. This then got me onto thinking about other things that you can do with looking at the Earth. So how can you measure the size of the Earth? And the bizarre thing is, you just have to stand up. And you think, what? So what you do is you find a clear view of the western horizon and you sit down, you watch the sunset. Then you immediately stand up, and because you're now higher, you can see the sun set for a second time. And using the difference in those times, you can calculate the size of the Earth, just using the difference in the heights and the two times that you've got there. So, and even if you don't do the calculation, it's fun to see the sunset twice, a few seconds apart. Right, I'm going to skip forward to the last bit now. So I've got a puzzle here for you, which again is to do with times, sunrise, sunsets, and so on. And here's the puzzle. Santa Claus always celebrates his birthday by waking up at sunrise and going for a walk. On his last birthday, he was staying at his home in the Arctic. When he woke up, he walked 10 miles south, 10 miles east, and 10 miles north, only to find himself back where he started. Now the question is, when is his birthday? I'll leave that with you for the moment, and I will come back to that in a few minutes. We said that there might be some questions.
I'll be well impressed if someone can get this.
Yeah, it's one of those things where when you've been told, you think, "Oh yeah, of course," but it's because of the way that we think about how things move around the sky. You don't naturally think of the right answer.
Poor Santa. Is that what he does for his birthday? Go on a triangular walk?
He's keeping fit.
Oh, yeah. Fair enough. Yeah. Okay. So what next then, Peter?
Right. So shall I give the answer now? People have been having.
I think give them a few minutes because there's an occasional delay. Go back to the picture again. Go back to the riddle, and we'll give them another chance. They love a good brain teaser. The popular astronomers do, Peter.
Right.
So let's have it again. Oh, hang on. Where's it gone?
Oh, is it not there at the moment?
Yeah, just share your screen again, please.
Oh, okay. Right. Sorry. Share screen. Window. Hang on.
Wait a minute. There are two types of. Sorry, stop everything. There are two types of seconds. You're using GMT seconds, but the international second differs from this to add to the confusion.
A second is a second. There's only one sort of second.
Wow, John, if there are two types of second, if there's a second, I'd be very interested. Peter doesn't second that there's a second.
No.
So that is very interesting.
There is an international definition of a second. It is so many oscillations of, I think it's a cesium-137 atom, and that's it. It's a large number of oscillations. Yeah.
Okay. Well, let's see if John can maybe somewhere. Sorry. Maybe the oscillation is slightly different in Britain, but let's see how John can dig his way out of the second hole. Okay. So, did you manage to share your screen, Peter?
I seem not to be, and I'm not quite sure why. Let's just try again. Right, so I'll make sure that I've got that up. I've got the presentation up. Okay, Now I'm trying to share that. Oh, share screen. There we go.
The difference shows up in the addition or subtraction of leap seconds on occasions. Well, that's even more confusing now.
Yes, yeah, there are leap seconds that we put in. Right, I hope that's got it.
Yeah, let's have a look. Okay, right. We'll come back to you later, John, because you're bamboozling us. Okay, Santa Claus always celebrates his birthday by waking up at sunrise and going for a walk. On his last birthday, he was staying at his home in the Arctic. When he woke up, he walked 10 miles south, 10 miles east, and 10 miles north, only to find himself back where he started. When is his birthday? Oh, okay. Great work, Peter. So we'll let them mull over that for a minute, and what's your next topic then?
Oh, that was it. You said keep it to 20 minutes. That was 20 minutes.
Oh, well done. Okay. Well, great. Well, Graham has had a guess. Graham Kluwer. I think Graham got the question right before us to where Cosmo, our little sloth, has been. I think Graham was the person who guessed Phobos. So Graham is on form tonight. 15th of March says Jed, and Graham says the 20th of March.
Okay. Those are both incorrect, but they're not far out.
Ooh, summer solstice. So Ian's completely wrong then. Ian, wrong. So it's around some. Oh, hang on a minute. Let's have a look. I'll come. Paul saying next week's annular eclipse crosses the North Pole. So for a couple of visible on every longitude and main time zone in the world. That's pretty cool. How cool to see an annular eclipse at the North Pole. Sam, better ask for some eclipse glasses for Christmas, Santa. Guessing popular astronomers will give you 10 more seconds. In the meanwhile, Cosmo will dance for 10 seconds. 10, 9, 8, 7, 6. Give us a shimmy. Shake your little booty, Cosmo. 5, 4, 3. Twerk it, Cosmo. 4, 3, 2, 1. Right, Cosmo has stopped dancing. The timer is over. When is Santa's birthday?
Right. It is the 18th of March. And the reason for that is, and this is what we don't think of, we're so used to saying that the sun rises in the east and sets in the west every day. Sun rises, sun sets every day. When you're at the North Pole, then everything's just going around and around, and the sun rises once a year. When it's above the horizon, it just goes around, and it sort of corkscrews up and up and up. It doesn't rise and set every day. So it only rises once in the year, and it sets once in the year. And that date happens to be the 18th of March.
Oh.
Yeah.
So does his weird little boring walk have anything to do with that riddle?
Oh, well, yes. Sorry, yes. I should have said that first. So the point about walking 10 miles south, 10 miles east, 10 miles north, and getting back to the same place, normally you'd, right, where's my finger? You'd start there, go down, along, and up. I'm falling off the edge here. Try and start further over.
It goes back to
mirror image. That's why I'm having difficulty with it. Right, so that way, down, along, and up. And you wouldn't be in the same place. But if you start at the North Pole, then you do end up back in the same place. So that tells you that he's at the North Pole. Oh. No big surprise there. But if you're at the North Pole, the sun only rises once a year. And it rises on the 18th of March. And so that's when Santa's birthday is.
18th of March, because is that the equinox?
It's not quite the equinox, because the sun actually takes several days to rise when you're at the North Pole. So we're used to it taking a couple of minutes to come up. It just appears and then it's up in the sky completely. But because it's doing this corkscrew motion very slowly going up, it takes a few days to get up from just appearing to being fully above the horizon.
That's a cracking riddle, and well done to the popular astronomers who nearly got it right. They were in the region. Well done,
Graham. On the right lines, yeah.
In fact, Graham and Jed between them pretty much got it right.
Yeah, they bracketed the answer.
They bracketed the answer. Cosmo
which is a good thing to do.
Cosmo will do a little twerk to say, well done, lads. Oh, Peter, thank you so much for coming on. And as you say, you were going to give us a great riddle. And yeah, that was some good back to basics, but also fiendishly complex astronomy that you can do just by standing up. I like that thing about... because I live by the sea, and was it the night before last I saw the sun go down into the sea? So that was good.
Oh, yes. Yeah, that's always very pretty.
So how do I measure what's the stand-up, what's the standing ovation one?
Oh, right. So, yeah. So sit down, actually as low as you can squeeze yourself down. And then watch when the sun rises. When the sun sets.
Yeah.
And as soon as it sets, stand up. And then a couple of seconds later, you'll see the sun set again. Oh, you seem to have frozen.
That's
there we
cool.
go. Back.
Isn't that great? I'm here.
Good.
Okay, Peter. Well, thank you for persevering with us, and thank you for entertaining the popular astronomers, and thank you, Eleni, for introducing Peter to us. It's been really good. We'd love to have you on again in a couple of months, Peter, if that's okay.
I'll do your black holes and radio galaxies then.
Oh, yeah. Oh, look. Have you seen my T-shirt? Look at my T-shirt.
Well, I happen to be going to give a talk about that. Not the T-shirt, but the picture on it in a couple of weeks' time.
And what's the theme of the talk?
Oh, it's about, how to take a picture of a black hole.
Nice.
Yeah.
Nice. Very good camera. Okay. Thank you. We'll catch you soon, Peter, and we'd love to have you back on.
Okay.
Thank you. Bye. Peter, Alan, everybody. Well done, Eleni, for suggesting that. And as I say, I apologize about the poor bandwidth. That was great. So I wonder whether I'd be able to get I need to know what the rest of the thing is. If you stand up, give the sunset a standing ovation, you can calculate the size of the Earth. Is that right? I'll have to get a stopwatch on that one. Right. Okay. Now we're going to go over. Oh, we've got 5 comments here. Let's have a look. Thank you for the mind benders, Peter. Yes, very good. Peter Allen's mind benders. Thanks, Peter. Absolutely fascinating. Well done. Let's have a look. Also, Eleni, she's your greatest fan. Thank you. Thank you, everybody. That was great, Peter. Nice one, Ian. Great. Okay. He's right. Robin's on the Pop Astro chat tonight. He's right. I've just checked it using SkyMap. It's a few days before the equinox. Of course, Robin checked it up. Mr. Double Check Robin. I never double check anything. In fact, I don't even single check. Why I'm not an academic. We're going to go over to Sonia now, live from Stockport, with a presentation about the asteroid belt with her new live streaming setup. It's Sonia. Hey. Oh, my favorite girl. How are you?
I'm good. How are you? How is everybody?
We're really good. You're looking radiant. We're loving your backdrop, Sonia.
I know. I try my best. It's hanging on top of the curtain.
How are you, my giggly girl?
I'm good. I'm glad it's Friday tomorrow. Yes.
Yeah, I bet it is. Look, the comments are flooding in. Everybody loves you, Sonia. Jim says hello. Thank you. Thank you. It's lovely to get audience response, isn't it?
It is. I'm getting a bit of a fan base now.
You are. Well, it's no wonder, Sonia. You're simply smashing.
I've got to try and share things now.
Great. So what are we up to now then?
Oh, I'm going to try. I don't know how. I've never done this before on here, so bear with me, everybody.
Are you streaming off your new webcam, or is this off your phone, Sonia?
This is off my laptop with the built-in webcam.
Hey, it's really good. And you thought that because it was like an old, like literally you had to.
Oh, I've got an old one. And I must have been thinking of a very old one. This must be a new one. I forgot that I completely. So it has got to be new.
Yeah, Sonia, you're looking great, and yeah, it just looks top grade. Actually, it's a not dissimilar picture to mine. So good work. So what's your presentation on tonight then?
I have decided we're going to go along the asteroid belt between Mars and Jupiter, and we're going to have a look at all the little rocks that you can find bubbling away over there. I've just got to find out how I actually.
Oh, in the meanwhile, I'll show you my belt. Look at that. It's a blinger. How's
Yeah,
that?
very glittery. Very
That is
glittery.
great, isn't it?
It's fab.
It's not as exciting as the asteroid belt, though. So, I've got the presentation here, Sonia, if you can't quite manage to do it.
Do I click on share screen or is it video file?
It's share screen, but it needs to be like, I've got it in my browser. It's a bit erratic if you try to do it from PowerPoint. Doesn't really do it on my computer. So I can do it if you want, Sonia.
Select window or screen.
I'll let you do that. So a while ago, we decided that Sonia was going to start doing astronomy presentations because we know that many of the SPA members are really clued up astronomers, but there are lots of people who are only beginning their very exciting journey in. That's why Sonia's presentations are going back to basics, but I guarantee there's pretty much always going to be something in the presentation that you don't know. So, it's coming through, Sonia.
I don't know.
There it is. Oh no, that's us. Okay, you're sharing our feed, so ditch that.
How do I get rid of that?
I'll tell you this.
Oh no.
Yeah, just get rid of that, Sonia. Remove. Let's have a look. Kick
how
from
do I get rid
studio.
of that?
No. It's weird the way it does it. I tell you honestly, it's the only problem with the software is that the screen share. So can you delete that feed, Sonia?
How do I delete the feed? I've got to stop the screen. Oh, there we go. Is that done?
Okay, so I'm now going to try and share my screen, and it'll go to your presentation, and we can do next asteroid. Okay.
Fabulous. Oh, I had a YouTube video as well on there. I wanted to share with everybody.
Sonia. So, okay. So can you see this now? Oh, hang on. There it is. Share. There we go. How's that?
Fabulous. There we go.
So,
I think that's the third slide, isn't it?
Oh, great. Always start a presentation from the last slide. There we go. Where's your first? That'll be the first.
There we go. So we're going to go amongst the asteroid belt, as I say, between Mars and Jupiter. So they're known as minor planets or rocky objects. Eros is the famous one as well. It's a piece of rock about 2 miles long. It is shaped as irregular and it rotates every 5.5 hours as well. I thought that was a good, interesting point to put in there for everybody. Next asteroid.
Never not funny. Go on.
So as you know, it's between Jupiter and Mars, and it's a ring-shaped donut. So it goes right around the sun, pretty much like the planet. It's made up of billions, thousands of rocky objects. They were detected in the 9th century, and 4 of them are like principal power minor planets, such as Ceres, the largest one. You got Pallas, Juno, and Vesta that we know of as well. Most of the asteroids in the belt as well, they take between 3 to 6 years to actually complete a full orbit around the sun. And they're classified depending on how they reflect and how they are with the chemical composition. So you've got 3 types. You've got type C, that is known as the I hate putting the words in again, I can't even pronounce.
Carbonaceous.
There we go. That's in the outer belt. We've got type S, which are made of the rocky compositions. They're in the inner belt. And you've got type M, which are the metallic asteroids that orbit in the middle of the belt. And they're the 3 main types of asteroids in the asteroid belt. Next asteroid, we shall go along. So there isn't just the asteroid belt. We also have Trojans and near-Earth asteroids within orbit. And other asteroids have trajectories that take them towards us. So when an asteroid comes within around 121 million miles of the sun, it is known as an Earth asteroid or an NEA. And some cross Earth's orbits, and there are around 500 known NEAs, but there could be thousands more at the moment. Trojans and near-Earth asteroids that are the sort of the ones that are the dangerous ones that could collide with Earth, and that's what the near Earth asteroid.
Good work, Sonia.
My last one.
Yeah. Oh, honestly, I tell you.
No.
Is there one more? Is that the end?
I think that's the end.
Oh, okay. Well, it's short but sweet, but that's fine, Sonia. Because to be honest, I'm. Oh, crumbs. I am slightly sweating now because of the internet.
I have just found out that I can share, so I'm just going to see if I can do this quickly because I really want to do that last presentation. No, it's not there. I don't know why. I don't know why at all. I'm picked on presentations, but my presentation is not in the file it's supposed to be, so I don't know.
Oh, nothing like doing. These are the perils of live streaming. It's basically just doing IT live on air. So how's the weather going, Sonia? We've had some fantastic weather. Thank you for your weather reports.
Absolutely gorgeous weather. It is going to be like all the way through the weekend, up until next week as well. That jet stream at the moment is slightly going to move across us though, which gives us a bit of cloud in the way for tomorrow. However, if I just go through Saturday night, it is looking really good. Saturday night, Sunday, Monday, Tuesday is starting to go a little bit partly cloudy next week. However, it is still looking good. There's not much in the way of rain at the moment at all. It is going to be dry. It is going to be stable. We have the high pressure still over us. The weather forecast goes up to next Wednesday at the moment. So I am looking very closely for the forecast, and I will do a live forecast as well to upload on Wednesday evening for that solar eclipse as well. Fingers crossed. Badar solar filter to put on my telescope to have in the back garden to have some really nice pictures, and hopefully get some videos as well to upload on the Pop Astro website. So I'm very excited. I've even got the day off next week, so fingers crossed.
Oh, you took the day off.
I took the day off. Well, I've got next Thursday, Friday and Monday off, so I'm really hoping Thursday morning to be able to get that telescope in the back garden. And hopefully I can see some sunspots as well whilst observing the solar eclipse.
Well, Sonia, we're doing a Pop Astro Live at the time of the eclipse. We're just organising it with Robin as well. So we'd love to have you along at the start doing the space, the observing forecast. So if you have, I just clacked my ankle. I've just walloped my ankle. We'd love to have you on, Sonia. And you know what I forgot to do? Because it's all just go on the show. It's all just go. Let's have a look. 3, 2, 1. Will it be cloudy? Will it be sunshine? Will it be hurricanes? Sonia's been checking out the jet stream and the humidity. Is it safe to get my telescope out, or will it blow over and bend? Well, Sonia's here with all the answers, my starry-eyed astronomer friend. You see, when you're doing a show yourself, thank you, Sonia, when you're doing a show yourself, normally you'd have a producer in your ear in the gallery. I mean, like, Nagamunchetti must have 30 people pressing buttons for her. She just sits there and looks clam on the couch, whereas I've got to do it all myself, and I've got this thing to deal with as well.
Oh, poor bless Cosmo.
Bless Cosmo. No visits from the cats tonight, Sonia.
No, I think they're in tonight. So yeah, no cats tonight. Although Bob was on the bed first thing this morning at 6 o'clock. I think he likes to do that to me. He opens the door, lets the cat in, and he comes plodding upstairs, drops himself on the bed next to me to wake me up.
Oh, that's so sweet. So Steve Fractal's the man with a trillion faces. Caught Saturn rising at dawn on Monday. Great to see him again. Yeah, we love Saturn and his old hula hoop there.
I keep seeing every time I get up in the morning, it's cloudy. So I'm hoping Saturday morning, maybe get the Saturday or Sunday morning to set the alarm and see how we go on. So I really want to see Saturn and Jupiter at the moment.
And David Graham says some nice sunspots at the moment. Have you seen them?
There's a sunspot. I think it's on the right limb of the sun at the moment. So I'm hoping to capture a glimpse of that next week as well.
Lovely. And Jed, thank you, Jed, for cheerleading us. You've sent some lovely things to us. It's really, really sweet. And we are aware that currently, at least for the first hour of the show, that you were two-timing us with Spring Watch. So that means a lot because Spring Watch is like amazing.
Oh,
So
I love Spring Watch.
thank you for choosing us over Spring Watch. You know, you can watch us all again, but it's better to join in with the fun live on. Chris Packham's never going to read your name out on Spring Watch, is he? Unless you send the most amazing photograph. And look,
next week I'll be doing a presentation, of course, on how solar eclipses happen.
that would be lovely. So Bob is congratulating you. Well done.
Thank
you. John Murrell says, Murrell, the sun is slightly larger in hydrogen alpha. So if you've got a H alpha filter, you should get a slightly longer partial eclipse. There you go.
Oh, I don't have one of that. I used to.
Oh. Hey, well, she's completely frozen. There you go. Right, I'm going to wrap the show up because me and Sonia are freezing. So I don't know how well you can hear me. I think because it's half term at the minute and the people are here eating the internet on Anglesey, the holiday island. So I think whenever it's school holiday times, I'm just going to bail out and have a hiatus because this is traumatic. Oh, but thank you everybody for your kind comments. Sonia, it's been lovely. Eleni, my sweetheart, my beautiful bendy Greek astronomer. You are just so wonderful, Eleni. Thank you for arranging Peter as a guest. Thank you, Peter. Thank you, Becky Smethurst. It's been wonderful joined in. No thanks to him. And Madeline down the set here tonight near Oxford. Well, go out and do the stand to attention with the sunset. See if you can calculate how big the Earth is.
They're going to post a photo on that.
Don't bail. It's still a great show. Oh, thanks, Steve. Oh, it stresses me out. Oh, thanks, Steve. Thank you. Okay, everybody, we're going to disappear off. Sonia, stay on the line. We'll have a little catch up, and it'd be really lovely if you join us back here next week. Post solar eclipse, there's either going to be some furious astronomers or elated astronomers. Which one will you be? Okay, great fun to watch. Nothing like live astronomy. We'll deploy the HA telescope. Thank you, Vicky and everyone. Great show. Jed, thank you. And you're probably our best commenter. See you all later. Bye. Share the video. Share the video. Share the video. Bye. Bye, bye, bye. Bye from him. Where's he going to be next week?